Mars has turned out to be a planet of extremes. As we've explored, we found some really interesting things. This is a volcano called the Olympic Mons. It's the largest volcano in the solar system. Its base is the size of the state of Missouri. That's a big volcano. We also see dust storms that cover the entire planet. Here's an example of two photographs that were taken, one in June and one in September. The one in June, this is where it was clear and you could see lots of things. Then a global-wide dust storm kicked up and obscured everything. So you can see what a difference that makes. Violent weather on Mars. It also has the biggest canyon in the solar system. The Mariner Valley is this thing here. It puts the Grand Canyon to shame. This thing is the length of the continental United States and almost 6 miles deep and multiple times wider than the Grand Canyon. Tremendous canyon system stretching across Mars. Now the big question in the news that whenever Mars pops up is, was there water on Mars? Some of the photographs we get back, I mean, it looks like there's water erosion that forms some of these things. We see what may be like little streams. We see what appears to be runoff here, and so on. You can go through this and find lots of features that look like they were formed by water. Here's another example, the Eberswalde crater. The crater itself is this thing, but I'm going to show you a close-up of that little box right now. It looks like this. Now this looks kind of like a river delta, doesn't it? Like at the mouth of the Mississippi or a large river that's been depositing sediment in this big triangular shape forms. That's kind of what this looks like. It looks like a big drainage thing for a river, doesn't it? Problem is, we're seeing some other things happen that look like, or that otherwise we would think were formed by water, but we know they're not because we've been watching. This ridge here, for example, here's a picture of it in 2002. 3 years later, we see that this erosional feature here has formed, and we know that's not, I mean, if you didn't know, you'd think it was liquid water because it looked like water runoff, but we know there's been no water there. So it's being formed by other erosional means. There's also photographs like this circulating in the media where they say, well, look at all those layers of sediment. You know, sediment was obviously laid down by water, so therefore Mars used to be underwater at one point, or at least large portions of it were. Now, why the big ruckus about water? Well, evolutionists love to speculate about water on other planets. You may or may not have noticed this in the news because they do the same thing. Since life obviously formed here by itself, but needs water to do so, well, if we find water elsewhere, that might mean life elsewhere too. And life elsewhere would confirm evolution, right? Maybe there's even intelligent life elsewhere, more highly evolved than us, so we can go learn from these ascended masters. Yeah, the New Age stuff works in evolution big time. Well, the Martians must be awfully thirsty because liquid water on Mars is actually physically impossible. Mars has a very thin atmosphere today, and as a result, even though it's very cold, the boiling point of water is very low because of the thin atmosphere. And if you did have a puddle of water, it would boil away in a few hours. You can't have liquid water on Mars. The problem is evolutionists want water on Mars really badly. In fact, some want enough water to flood the entire planet. This creates a problem, doesn't it? You see, Mars used to have a bigger atmosphere, enough to accommodate water, but then a long time ago an asteroid came along, smashed into Mars, stripped away the atmosphere, and it's left with what we have today. Now this is total hypocrisy. Think about this. There can't be water on Mars. We know this. I mean, we've had spacecraft there taking samples and taking pictures. But they want a global flood there for various reasons. Therefore, they had this asteroid that created a one-time catastrophe. On the other hand, Earth is covered with water. There's more than enough to have a global flood here, but we're mocked for believing in one because catastrophes are unscientific. Another factor here is that a lot of the so-called water-like features on Mars have other explanations. For example, there's a thing called the thermokarst, whereas when you have ice in the ground, if it melts, the ground collapses in such a way that it looks like water ran off. And I showed you the example also of the gully that's been eroding as we're watching with no water being present. So we've seen a lot of these things form without water, yet they insist that there must have been water there anyway, even though there can't be. Also, we've taken soil samples by some of our probes, and we found only trace amounts of carbonates like limestone, which would have indicated that water used to be there. In other words, we're looking for things that were, for chemicals that would be formed by water if it was there, and we're not finding them. On the other hand, we are finding minerals like olivine, which break down in the presence of water. So we're finding chemicals that are telling us water didn't used to be there either. So here's what you're not being told about Mars. Next time you hear a news story about all the evidence we're finding for water, maybe there's life there, First of all, the so-called evidence for water has other explanations. It doesn't have to have been water for those features to be there. Number two, water is impossible there today anyway, and saying that it used to be there is hypocrisy because of the way they criticize us for believing in a global flood in a planet that's covered with water. How are we doing so far? Is everybody awake? Okay. I'm worried about showing you pictures of the night sky, late at night here. I mean, people be nodding off. Okay, next out from Mars are the planets called the gas giants. There's Jupiter, Saturn, Uranus, Neptune, and you are here. Not right next to it, but just for purposes of size, to show you how big these objects are. The first one is Jupiter. Jupiter is sometimes called the king of the planets. It is by far the biggest. Jupiter is famous for this feature here called the giant red spot. This is a huge storm going on in Jupiter's atmosphere. It has been there for as long as we have been observing the planet. So for all we know, it might have been there since creation, thousands of years. Or it might have just started a couple hundred years ago. We don't really know exactly, but it's been there as long as we've been looking. To give you some perspective, here's the Earth compared to the great red spot. So imagine a tornado bigger than the Earth. That's what this thing is. Now, Jupiter provides a unique challenge to evolution. I told you about the fact that the planets can have various times of rotation around their axis. It takes the Earth 24 hours to get around our axis. Jupiter spins on its axis once every 10 hours. Imagine something this big spinning around in 10 hours. That thing is just screaming. The problem is, under an evolutionary scenario, how do planets spin? Why do they have spins at all? Well, because as these rocks were forming and aggregating into these big planets, of course, the rocks would come in various directions because this is all random, right? I mean, there's no intelligent creator, steering any of this. So the rocks are going to come in at different directions, different angles, different speeds. And sometimes they'll hit on one side, which spins the planet this way. Sometimes they'll hit on the other side, which spins the planet around the other way. So in general, all these impacts should more or less cancel each other out, right? Because it's all random. So it actually turns out to be kind of difficult to get a planet spinning at all in these evolutionary scenarios, much less to get something this size spinning around that fast. Here's a quote from an evolutionist who's been working on the problem. We came to the conclusion that if you accrete planets from a uniform disk of planetesimals, prograde rotation, prograde meaning in the expected direction, prograde rotation just can't be explained. The simulated bombardment, all those rocks flying in that I told you about, leaves a growing planet spinning once a week at most, not once a day. So Jupiter should not be spinning around as fast as it is, unless there was some sort of non-random element to all these rocks coming in, but that's out of bounds, because that would, that would interfere with evolution. Another question, where did Jupiter come from? Here's a quote from Nature Science Update. Jupiter is the largest of all the planets, but results in nature now reveal the embarrassing fact that we know next to nothing about how or where it formed. As we've sent space probes to Jupiter and sampled its atmosphere, and I shouldn't say sampled, measured its atmosphere, it turns out that the things we expected would be there aren't, and stuff that isn't supposed to be there is. Jupiter was supposed to match the predicted composition of that early cloud of gas and dust. I mean, since Jupiter formed out of that cloud and it's basically a big ball of gas still, then the gas should match the gas that it came from, but it doesn't. So Jupiter's composition doesn't match the predictions of the nebula theory. Jupiter also has some really interesting moons. We could spend the whole evening, actually each of these things we could spend a whole evening on. But here's a small sampling of some of the puzzles that Jupiter's moons have provided for evolution. This moon is called Io. It's a little tiny thing. Let's see, do I have... There's a picture in here. Well, it's later on. A picture of a shadow of one of these moons so you can see how small they are. These moons are tiny compared to Jupiter. Io is this weird-looking thing here. And we didn't think much of it until we flew the Voyager spacecraft by it in the 1980s. We found some very strange things on Io. Io is covered in enormous volcanoes. This one here has been named Tvashtar. And look at the size of this thing. I mean, compared to the planet itself, that's a substantial fraction of the surface just of this one volcano. And Io has others besides these.